one of the things that I find most useful when trying to determine like the mole mass or the formula mass of a compound is you want to separate each element, individual element, with their subscript. So we can kind of go ahead and do that here. So we have these guys together. Carbon doesn't have any, oxygen with a subscript of 3, and then OH with a subscript of 2. So the 2 kind of goes, whenever there's like the parentheses, it's basically like math, you just distribute it in. So now we know that we have 2 oxygen and 2 hydrogen. That's what this is telling us. So yeah, so we have all this. We have, you know, we separated the compound, so now we can go ahead and look at our periodic table. So my answer and your answer might be a little bit different, just because each periodic table has very like different values, just by a few decimal places. So I'm gonna go ahead and use my little laminated periodic table. And we'll look for copper and the mass. Oops. According to the periodic table for copper, is 63.55. And then we have the mass according to, for carbon, is 12.01. Oxygen's always 16. And then hydrogen is 1.008. So that's what you want to start off with. You want to identify which elements you have in your compound, write them out. It looks like we have all of them. We have copper, we have carbon, we have oxygen, hydrogen, we have all of them. So write them out and then write their mass. And then what you want to do from here is you're going to then multiply it by their subscripts. So copper, we see we have 2. So we're going to multiply this value, the 63.55, by 2. So the carbon, we have, let's see, we have just one, so we're going to leave it as is, or if you want, you could just put like a 1. Oxygen, we have 3. So we have 3 oxygen plus these 2 oxygen for a total of 5. So we're going to multiply this by 5. Not least, for hydrogen we have 2, so we're going to multiply it by 2. Okay, so then do your math. I'll do it with you. So we have 63.55 times 2, that gives us 127.1. Carbon is just 1, so we add 12.01. 16 times 5 is 80. And then hydrogen, this should be about 2.606. Let me double check my math. Yes. Okay. So here we kind of multiply across, and then we have the mass basically for each individual element. So what we want to do is add all of these values together, right? So you're going to add that plus 80 plus the 2.6 plus 12.01, and it gives you 221.126. Round it up to the correct amount of significant figures. At least in my case, we have about 2 to 1.13 grams per mole.